This video will talk about the second half of section 5.6. We'll reuse the laws of logarithms that we learned in class and apply those to help us solve logarithmic equations. Much like when we solved exponential equations earlier in chapter 5, there are two types of log equations. We're going to talk about the goal for each of those here. You can have logs on both sides, and there's an example of that down here. Your goal there is to get a log on each side and then be able to drop them. So remember we talked about in our laws of logs, if you have log of x equals log of y, as long as the bases are the same, then x must equal y. So if we can get down to that point, that'll help us get to our variable. If you only have logs on one side, the example of that is down here. You want to follow a similar idea as the first type, just on one side though. So we want to get the left side with the logs down to one log, and then we'll be able to do the loop in order to solve for the variable and get rid of the log that way. So in number 1 here, we can see that we have logs on the left and logs on the right. So remember, our goal is to try to get one log on each side. So if we look at the left side, we have log x minus the log of 4. We know from our laws of logs, that can be written as the log of x over 4. We can set that equal to the log of 2. Now we know since these are the same bases, we know there are little imaginary 10s here. We don't need to write these in. But we know the bases are the same, so now we can take the x over 4 and set that equal to 2. So if we do that and say x equals 4 equals 2, then we get x equals 8. So again, by getting down to just one log on each side, we're able to drop those and solve for x. In example 2, we have logs on the left side, but not on the right side. So what we need to do is simplify the left side as much as we can, and then hopefully we'll be able to use a loop from there. The first thing we notice is that we do have a coefficient here of 3, so we know we can move that up as an exponent. So if I rewrite this, this is really log base 2 of x plus the log base 2 of x cubed equals 4. If I continue to try to simplify that left side, since these are being added, we can multiply the x and the x cubed. So on the left side now we have log base 2 of x to the 4th equals 4. And now we've achieved our goal. We have just one log on the left side. So now if we do our loop, we want to do 2 to the 4th equals x to the 4th. And if I write that, I actually don't even have to evaluate anything. Since the exponents are the same, the 4's are the same, we can simply write x equals 2 and be done. You also could have evaluated and said 16 equals x to the 4th, and that would have led you to the same answer. That's a 2, sorry. We still would have gotten 2 there because you know those powers. In problem number 3, again, we have logs on one side, but not on the other, so we want to try to loop again. We first need to combine that side. This problem is going to be a little more in-depth and one you definitely need to know how to do for your quiz. So on the left side, we have no coefficients, so we're not moving anything up to exponents. We have an x over here and an x plus 6. Since these logs are being added, we can multiply those. So this becomes the log base 3 of x times x plus 6 equals 3. In other words, the log base 3 of x squared plus 6x. And now that we're down to just a single log on the left side, we can start to loop. So remember, we take the small number and go over and back. So when we rewrite this, we get 3 cubed equals x squared plus 6x. 3 cubed is 27. So now we have a quadratic. What this will hopefully cue you to do is move everything to one side. We are going to have to factor here. So I could say 0 equals x squared plus 6x minus 27. When I factor that, I end up with x plus 9 and x minus 3. You can recheck that by foiling. When we set both of those equal to 0, we end up with our values for x are negative 9 and 3. Here's the last thing we need to check. We know from the graph of a log, and if I just sketch the general function here, we talked about the domain and that x has to be greater than 0. That means that in all your answers, x has to be greater than 0. So for this particular problem, x equals negative 9 actually can't be an answer because it doesn't fit in the domain. So your only answer to this problem is x equals 3. So this had a lot going on. We had a quadratic, we had to factor, And then at the end we ended up with a negative answer, so we had to get rid of that because it's restricted by the domain. For this last example, this is going to turn into another loop. We've had a lot of those where we've had logs on one side but not the other. So again, we have addition in the middle here. So if I add those things together, I can multiply the x plus 2 and the x minus 2. So we have log base 3 of x plus 2, x minus 2 equals 2. If I FOIL those, multiply those together, we have x squared minus 4 equals 2, and now I'm ready to loop. So if I do that, I'll draw these arrows in if you're still a little bit stuck on how to do that. We end up with 3 squared equals x squared minus 4, or 9 equals x squared minus 4. If we add the 4 to both sides, we end up with x squared equals 13. So x here is going to equal plus or minus root 13. When you take the square root of both sides, we always get a plus or a minus. However, we know from the domain that x here can't be negative root 13 because we can't take the log of a negative, since again it's restricted by the domain. So your only answer here is going to be x equals just positive root 13. Again, we can't have any negatives in our logs, and if you plug that in for one of these equations, you'd end up with a domain restriction. So be careful of negatives there.